We have spent the last couple of years typing questions into chatbots and waiting for text to appear. But we are moving past that prompt and response era. The next evolution is Agentic AI, systems that autonomously execute complex, multi-step workflows. Instead of asking an AI to write a snippet of Python, an autonomous agent can write the software code, test it, and deploy it. If a server goes down, an agent can detect the anomaly and remediate the incident on its own. In an enterprise, they can ingest and audit thousands of highly secure, proprietary documents without human intervention. The core processing power of these agents is still a large language model. However, the LLM operates differently here. It functions as a reasoning engine, breaking down a massive objective into a sequence of smaller, logical steps. There is a massive catch. By default, an LLM is entirely isolated. It is a stateless entity. The moment a session ends or the token limit is reached, its context window empties out, and it forgets everything that just happened. To actually do work, it has to be forcibly connected to external systems. Because of that constant memory wipe, these models rely on Retrieval-Augmented Generation, or RAG. When an agent needs to recall a company policy or a historical data point, it converts its query into a vector embedding and pulls that specific piece of context from an external vector database right before it generates a response. Connecting an LLM to those vector databases and to third-party APIs requires massive amounts of custom integration code. Every new tool demands distinct authentication protocols, different data models, and complex error handling scripts. Inside a large enterprise, this friction compounds quickly. You might have web teams deploying microservices on Kubernetes, data engineers managing pipelines in Airflow, and machine learning teams SSHing directly into custom boxes. Everyone is using disjointed toolsets to manage what is ultimately a single workflow. Look at this network graph. The orchestration layer quickly becomes a catastrophic bottleneck. Highly skilled developers are forced to spend their days untangling data pipelines and debugging basic connections instead of designing better AI logic. The capability of autonomous agents is already here, but their deployment is entirely gated by the logistical nightmare of wiring all these disparate components together by hand. That is where Langflow comes in. It is an open-source visual studio that replaces those mountains of brittle integration code with an intuitive drag-and-drop architecture. Langflow takes highly abstract AI infrastructure, vector stores, document loaders, memory modules, and turns them into tangible, color-coded functional blocks that sit on a blank digital canvas. To build an agent, the first step is establishing the central engine. You grab your model node and pull it right into the middle of the workspace. This schematic outlines our architecture, focusing purely on that large central concrete block. That is the Anven model from Treecapital AI. We place Anven at the core because it is a highly deterministic, sovereign large language model designed specifically for secure, precise enterprise reasoning. By placing this single block on the canvas, a developer establishes a secure cognitive core without writing a single line of back-end routing logic. To solve LLM amnesia, we pull document loaders and a vector store module onto the board. These nodes wire straight into Anven, establishing a RAG pipeline that pipes proprietary data into the model to ground reasoning. Now the agent can think, and it can remember. But to execute tasks in the real world, it needs hands. The Model Context Protocol, or MCP, is a universal interface allowing AI agents to securely communicate with external systems. Looking at the top agentic layer block, this routes the engine's logic outward, granting Anven autonomous control over designated APIs. We have assembled a complete autonomous machine, featuring a brain, a memory, and hands. We mapped it using entirely visual logic, bypassing weeks of tedious back-end coding. Once those nodes are connected, you can immediately test the agent's chain of thought reasoning using Langflow's built-in playground. This interactive sandbox lets you watch the agent evaluate its toolset and execute tasks in real time. If the logic falters, you adjust the parameters directly on the canvas and try again before a single piece of code goes to production. Watch this transition. With one click, every visual canvas you build automatically compiles down and generates its own dedicated API endpoint. Historically, pushing an AI workflow to production meant agonizing over access keys, environment variables, and custom routing scripts. Now, it is an instant, seamless deployment. Langflow, powered by Treecapital's Anven AI, solves the mechanical friction of manual wiring. It moves the engineer from AI plumber to AI architect, shifting the focus from making components talk to making them perform. Visit treecapital.ai to start building your first workflow today.